we've been talking about magnetic fields, but really we've just been talking about little arrows and right-hand rules. We haven't done anything with numbers yet. We haven't even talked about the unit. So let's get the unit, and then maybe, pretty soon, we can actually work a problem. So the unit, you can find it by looking at the force equation. So F equals Q V cross B. So if we think this is in newtons, and this is in coulombs, and this is in meters per second. So the unit for B must be in newton seconds per coulomb meter. And that has a name, that's called a Tesla, after Nikola Tesla, or we abbreviate it with a big T. So that is the MKS unit for the magnetic field, the Tesla. That is a really big field. Just like a coulomb is a really large amount of charge, a Tesla is a pretty large field compared to sort of everyday objects. So we have another field, or another unit that we also use. So we can say that 1 Tesla equals 10,000 Gauss, which we abbreviate with a G. So Gauss is another unit of the magnetic field, and it's not 1,000. You know, usually we have these things always changing by factors of 1,000. This one happens to be 10,000. Okay? So let's look at a few fields, just to give you some order of magnitude before we think about some problems. If we look, we know that there's a magnetic field at the Earth's surface. That's why magnets work. And it's about 0.5 Gauss, depending on where you are on the Earth's surface. Another thing would be, say, a refrigerator magnet. Those little black magnets that are common are stronger than the Earth's magnetic field. They can hold something up. They don't just barely turn a needle. And they're, I mean, it depends. They're roughly 100 Gauss. Okay. The last decade or so, we now have these new rare earth magnets, these neodymium, samarium cobalt, all these really strong magnets have become easier to make, and you can get them. And they have much stronger fields. So let's say a neodymium magnet. The ones that made the magnetic earring possible are much higher. They're up into the thousands of Gauss, say about 5,000 Gauss. And of course, it depends quite a bit on how big it is and what its properties are. They can get up to a Tesla. They can be down in the low thousands of Gauss. Another big magnetic field you might experience is if you get an MRI, when you have to lay in that tube, giant magnetic fields. MRI, if you go to the hospital, typical MRI, now we're up to Tesla. A couple of Tesla. Maybe higher, maybe lower. So we experience magnetic fields over quite a few orders of magnitude. If you want the biggest magnetic field, you go to Florida. You go to the Florida State University National High Magnetic Field Laboratory. It's in Florida, makes me nervous, and it is at 45 Tesla. And they will tell you that that is the biggest man-made magnetic field, but actually it isn't. That's the biggest constant man-made magnetic field. You can also get it a little bit higher. You can have one that just lasts briefly, have a current, instead of big superconducting coils making, continuous current making a field, you can just pulse some current and try to make it higher. If you do that, you can get up into the hundreds of Tesla. And then, if you're willing to destroy the equipment, if you're willing to just do it once, you can send such a huge pulse that you can get up into the thousands of Tesla. It's like you set it up, bam, the current hits, thousands of Tesla, everything's melted and destroyed. But if you want to do a nice calm DC experiment, 45 Tesla is pretty much the top.